I am the priest of chaos and the pope of fractals. Often you heard chaotic, self-similarity, recursive, complex, or chaotic. All of such words have different meanings. My mission is to enlighten you in each of those, but in different sessions. We start now with explaining the word fractal. And as a starter, this is not fractal. It is just iterative. And okay, it all started when Mandelbrot published his How Long is the Coastline of England paper? We Carry Your Spirit. And measuring coastlines is always a process of approximation. The smaller the measurement scale gets, the closer you approach the real length of the coastline of England. According to Wikipedia, when using a linear scale of 100 kilometers, you get a resulting length of roughly 2,700 kilometers, and when, as opposed to exactly halved scale of a ruler size of just 50 kilometers side length, you get coastline length of 3,400 kilometers, according to Wikipedia. And this is a most crucial part of what the meaning of the word fractal is. Most people don't get this behavior of measuring processes on the first sight, so I will explain it to you on my little board. And I have prepared two scales for measurement, and we have the 4 unit square and the 1 unit square, which fits exactly 2 times on each side and 4 times in the whole area. Now I'm going to measure the side length of this object with the doubled side length. So we have 2, 4, 6, 8, 10. This is the same 12, 14, 16, 18, 20. As opposed to a side length result with this 1 unit scale. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And as before, we can double, it's 28, but I will show you just that you don't believe I trick on you. It's 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. And this is basically it. You have a different measurement scale, and thus resulting in a different result. And this behavior is not visible on pure Euclidean objects like this rectangle here, because we know we have side length 2, and we have 2, 4, 6, 8, 10, 12, and when measuring the object with a halved measurement scale, we come to the same result. But I show it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what Mandelbrot, We Carry Your Spirit, did was to apply the already known Hausdorff dimension to real objects. The Hausdorff dimension is a way to assign a number to mathematical objects. And it basically applies 0 to a point, dimension 0, a point has dimension 0, a line has dimension 1, a square has dimension 2, and a box would have dimension 4. But the most interesting part of the Hausdorff dimension is that it can be as well a non-integer dimension. And what Mandelbrot, We Carry Your Spirit, did was to apply this to real objects, and according to Wikipedia, the fractal or Hausdorff dimension of the coastline of England is roughly 1.25, which means when halving the measurement scale, you get a longer coastline length of roughly by a factor 1.2. And this basically wraps it up for the meaning of the word fractal. It is no more and no less than objects that behave oddly under different scales. And you might have guessed, all around us is fractal. And that basically is it. And I have some additional information for you. The meaning of the word fractal comes from the Latin word fractus, and it means broken. And in the English-speaking countries, you use saying I have a fractured leg to report a broken leg to your family or friends. And I have some additional information prepared, and you ask, who is using it? Who needs it? And the fractal dimension is already used by industries of different kinds, and I shall give you 3 examples of what can be done with the fractal dimension. First thing is, you can assign a fractal dimension to an atomic scale surface analysis, where the goal is to achieve surfaces that have extremely adhesive or cohesive or sliding properties that have already been developed. And the second point is, according to the book Chaos from James Gleick, nowadays pacemakers analyze the fractal dimension of the heartbeat, because the human heartbeat isn't as regular as you might guess. It is chaotic. It has an irregularity that needs to be observed by the pacemaker by assigning a fractal dimension to the heartbeat. And when the heartbeat's fractal dimension or the Hausdorff dimension approaches an integer value, the pacemaker does burst and brings back the heartbeat to a more irregular state or a chaotic state. And last thing is, remember the old days of the mobile phones in the 90s of the last millennium, where each of the phones had those little antennas popping out of the backside of your phone. And since the end of last millennium, the fractal antenna was introduced. And the fractal antenna provides an incredible length of antenna, but using just a square centimeter on your mobile. And thanks to chaos theory, this has been overcome. Thank you for watching. See you next time. That was basically it. Ciao.